ANSYS Simulation Lecture 7, Pre-stress effect in modal analysis. Open a part file. And in XY plane, enter sketch mode and draw two circles. And this will be a CD plate. So in the inner circle, I'll make it 10 millimeters in diameter, and for the outer circle it is 120 millimeters, and I'll extrude it to 1 millimeter. So this will be the 3D model for CD plate, and I'll save it on desktop. And then I'll enter ANSYS workbench. And the first interface in ANSYS will be project schematic. The project schematic is the organizing interface for ANSYS. So the SolidWorks model is already linked to ANSYS workbench, and I'll simply drag static structure and connect it with the geometry, and then I'll run model analysis in serial mode with the static structure analysis. So then I will edit material by entering material procedure and change to data source and choose general material. I will choose polyethylene. For CD plates, I wanted to choose polycarbonate PC, but there's no polycarbonate in the library, so I choose polyethylene instead. So now I'll enter ANSYS mechanical interface. And actually, ANSYS mechanical is a procedure where all the CAE procedures are implemented. So after we enter mechanical interface, first of all, we will link the material with the geometry. So I'll choose material and make it linked to the geometry. So I finish with the geometry part, which is the step 1 of CAE analysis. And material will connect it to the geometry, and this is step 2. Step 3 will be mesh, and I'll update the mesh. And for step 4, I'll choose static structure, and then I'll add a fixed support on the inner circle here. I'll clamp the inner circle. Okay, apply. And for the rotating speed, I'll choose inertial. And this is the acceleration and gravity. I need to choose rotational velocity. And first of all, this is the body for the rotation. I'll choose the whole body already. This is the whole body. And the direction of a rotation, I'll choose this face and toggle the direction so that it is counterclockwise. And for the magnitude of the rotating speed, you make sure that the unit is proper, because the default unit will be radian per second, but it is very difficult to use. So I suggest that you choose RPM as the unit for rotating speed, and I'll enter 60 RPM for now, a very low rotating speed. And I'll define total deformation and stress for the static analysis, and I'll run the analysis. But be sure that you don't press solve here, because if you press solve here, the process will run static structure analysis and also model analysis at the same time. So for now, I'll run the static analysis, so I solve here instead of here. So I will only implement static analysis. And this is the static analysis result, the displacement, and it seems to be right. So now I'll go ahead and and proceed with the model analysis. You can see here that the pre-stress condition is connected or linked to static structure analysis, which is here. So the result of static structure analysis will be a pre-stress condition for the model analysis. So that's how I did here, because the static structure analysis will be linked to model analysis. So this is the pre-stress condition for model analysis. So now I will first of all I'll change the number of modes for calculation to 11 frequency and modes, and then I'll calculate the frequencies. These are the natural frequencies for lower velocity rotation. And now I'll change the velocity to a higher velocity of 2400 RPM and run the whole process over again. And now I'll run this again to make sure that the frequencies will be displayed here. Okay. Here is the frequencies for higher rotating speed, and we can compare the natural frequencies for both systems. That in higher rotating speed, the natural frequencies will be higher to 65 Hertz. For lower rotating speed, it is only about 50 Hertz. So we found that when you use higher rotating speed, the result will be higher frequency. Natural frequency will increase with increasing rotating speed. And as I said before, that external force does not affect a natural frequency of a structure, but rotating speed is actually a form of external force. But how does it change the frequency of a structure? And the fact is that the static structure analysis gives a pre-stress condition for the model analysis. In other words, the rotation of the CD will increase the internal stress, and the internal stress will stiffen the structure, so the rigidity or stiffness of the structure increases. When the stiffness of a structure increases, the natural frequency of the structure will also increase. So in this problem, it is very important to note that external force does not play a role in a natural frequency or model analysis. And only through pre-stress condition can an external load change the natural frequency of a structure. So that is very important that you distinguish from external force. That if an external force change the pre-stress condition or the internal stiffness of a structure, then the external force will change natural frequencies. If the external force does not change the stiffness of a structure, then the external force will not affect the natural frequency of the structure.